Right. So we're doing log graphs now. And very important topic. You might be asked just to state the gradient or something like that, or to write a log equation in linear form. And you might be able, you may, they might ask you to draw the graph, not sketch it there, draw it with actual graph paper and your best fit line and all that. So that's what we're doing. Okay. So how could this question come? Well, they might give you an equation that looks like this. Y is equal to AB to the power of X. They might give you an equation that's in this form and then tell you, using this, so using this right here, this equation that they gave you, they would want you to write it in linear form. And when we were doing coordinate geometry, we learned that linear form is y is equal to mx plus c. So what do they want you to do exactly? They want you to write this, so this, like this. The question is, how? How exactly do I go from y is equal to ab to the power of x and write it in the form y is equal to mx plus c? Well, this is the rule, right? Let me just erase. The rule is, the first thing you want to do is to add log to both sides of the equation. So what I would do here, I would put log. So remember, when we see log by itself, that means log to the base 10, right? So it's implied that this is log to the base 10. So I would write log of y is equal to log of ab to the power of x. So that's the first thing you want to do. First thing you want to do, write log on both sides of the equation. However, remember our goal is to write it in the form y is equal to mx plus c. If you look here, this equation that we have right now, this is not in the form y is equal to mx plus c. So what do we do here? Well, you have to simplify. You need to get it into this form. So not really simplify, but rearrange the equation to get it in this form, y is equal to mx plus c. So what's the second step then? Well, we know a rule, the second step, we know a rule that states, and we did this when we were doing logs, right? N log of m to the base a is equal to log of m to the power of n to the base a. So what does that mean for me exactly? Well, I can rewrite this equation as log of y is equal to, I see x right here, x is the power, just like this. And according to my rule, I could put this x in front here. So what do I get? So let me just show you the R of this. So what do I get here then? Is x log, oh gosh, no, hold on. I have to show you something before that. Okay, hold on, sorry, I am so sorry. We know a rule that states log of n to the base a plus log of m to the base a is going to give me log of nm, so n times m to the base a. And I could apply that rule here. According to my rule, this, you see right here, this right here, log of ab to the power of x can be rewritten as, this is equal to log of a plus log of b to the power of x. Everybody following so far?
Yes, miss.
So that was my mistake, right?
Yes, miss.
Now we could apply the law I was showing you just now. Step 3, this is log of y is equal to, so remember the law, n log of m to the base a is the same as saying log m to the power of n, and this also to the base a. So what does that mean? So I still have my log a, but you see this log of b to the power of x, what I can do, I could rewrite it as plus x log b. And that's just following my rule, right? So according to this rule, this would come here, or if I'm coming in this side, then this would come here. And that's what we did, right? Remember, we did these rules already. If you look at this now, look at the equation that we have. I just erasing this top part here, right? Okay, let me erase the whole thing. I'll draw it. So I told you what we have now. That last line that we had was log of y is equal to log of a plus log b, x plus log b. Remember, our aim right now is to write it in linear form. What do I mean by linear form? We want it in the form y is equal to mx plus c. If you look at this right here, let me just move this down a bit. Y is equal to mx plus c. So that's the form we want to write it in, right? If you look at this, look at the equation that we have now. If I rearrange this equation to get log of y is equal to x log b plus log a, what can I say? Well, I can say that this is y, this m, this is x, this is c. And now I have it in the form y is equal to mx plus c. Well, xm plus c, same thing, right? Everybody good with that so far?
Yes, miss.
Yes, miss.
And that's 2 people. What about the others?
Yes, miss.
Okay, what about the others?
Yes, miss.
Okay. I mean, I don't even know who's in the meeting right now. Was that everybody? I don't know if that was everybody. I can't see. Okay, well. Okay. So that's how we write it in that form, right? And I don't know. So did you learn how to draw a graph? Did everybody learn how to draw a graph yet?
Yes,
Yes,
miss.
miss. Yes, miss.
Okay. Well, you know when drawing a graph, then it's y. So these are my y values on x, right? You know about that?
Yes,
Yes,
miss.
miss. Yes,
Okay.
miss.
Okay, nice, nice. So if I gave you this right here, gave you this equation. So I said, let me not use the LG. Log of y is equal to 0.47x minus 0.6 0.65. Remember, we said just now, we worked out just now, that this is the linear form, right? If they ask me to find the value of B and then to find the value of A, what do you think we would do here? Anybody? So look at the equation they gave you and then look at what you know. How do you think we would find the value of B and A? Anybody wanna attempt? Okay, well, if you look at this, right? So we said this here, gosh, let me just write it over here. Log of y is equal to let me use this one, b plus log of a. Remember we said that this is y, this is m, this right here is still x, and this is my c. If I compare this equation, so this is the linear form, and then I compare it to what we have here, what can I say? If I look at this, right, this is considered my m, which is gradient. Let me just erase this. The 0.47 is my gradient, which is m. And then this minus, so negative, 0.65. That is my c. This is x. This is y. So if they wanted me to find the values of b and a, what would you say? You would say that, okay, m, gosh, I really have space on this. Okay, m, which is my gradient, is equal to log b, like what we were saying here, right? Log b is m. It's my gradient. And then you look at your equation that they gave you. In our equation, m, the value of m is 0.74. So what would you say? M, which is the gradient, is equal to log of b. And we are given that in this particular example, this is equal to 0.47. So if I wanted to find the value of b, log of b is going to give me 0.47. And using my rules for solving logs, I could find out what the value of b is. Everybody following so far? If not, let me know. I'll explain it a different way. Following? No?
Yes, miss. Understand.
Okay, that's one person.
Yes, miss.
Miss, I think
Yes,
I understand, but not really sure.
Not really sure. Okay. We just found out that the linear form is this. Where this is y, this is m, this is c, and this is, well, this is x, right? So let me put an equal sign. So I have a uniform y is equal to mx plus c. Y is equal to xm, mx, same thing, right? Okay. And then I gave you this equation. So this is just an example. Say that they gave you this one, this equation, log of y is equal to 0.47x. So this is just an example, right? Minus 0.65. And they ask you to find the value of b and find the value of a. Well, you need to determine how exactly you're going to find those values. This is how you find them, right? We know that m, just looking at the linear form, right? M, which is the gradient, is log b. So I would say, okay, m, which is my gradient, is equal to log b. And they want me to solve for this value of b. But how exactly am I going to do that? Well, I know from the example that m, which is my gradient in this case, is 0.47. So I can say here, m, which is 0.47, is equal to log of b. And by using the rules of log, I could solve for the value of b. So let's just do this one, right? Remember, whenever you see log by itself without a base, we assume that the base is base 10. When you look at this, right, you would be able to tell, I hope, that this is log form. This here is log form, right? Remember, log form is this. Log of x to the base a is equal to n. Remember, the rule says if we're given log form, then we could write it in this form, exponential form. Oh gosh. A to the n is going to give me x. That's how we solve logs, right? That's what we were practicing before. So just erasing all this so I don't have to make things on the screen at the same time. They asked me to solve for the value of b, right? And I said 0.47, which is the gradient given to me in that particular example, is equal to log b. How do you solve for b? Well, you just use the rules of log. That's in log form. So according to my rule, I can rewrite it into exponential form. We said we're assuming that this base is base 10. So if I rewrite this into exponential form, what I'm going to get is 10 to the power of 0.47 is going to be equal to b. That's just rewriting it into exponential form, right? Log form. Exponential. So that's just me rewriting it into exponential form, right? And if you punch into your calculator 10 to the power of 0.47, what you're going to get is 2.95 is equal to b. So in this question, if they ask me to find the value of b, this right here, that is my value of b. You understand what I was trying to tell you? Troy?
Yes, miss.
If
Miss,
you do,
miss, what do you say about calculator, miss? 10 equal 0.5.
10 to the power 0.47. This.
I see.
Everybody's following what I was saying so far?
Yes, miss.
Okay. If they wanted me to find the value of a, I said, looking at your equation, that log of A is going to be equal to 0.65. Right? Based on what we know what the linear form looks like. And then in our question, they told us that log of A would be equal to negative 0.65. Same thing, using the rules of logs, I could solve for A. This right here, that is log form. So according to my rule, I can rewrite this into exponential form. A to the power of n is equal to x. That's exponential form, right? So what does that mean for me? I can rewrite this as 10. Remember, 10 is understood, right? To the power of negative 0.65 is going to be equal to A. So if you just put into your calculator 10 raised to the power of negative 0.65, what you're going to get is A, the value of A in this case, is going to be 0.224. And this would be an answer if they asked you to find the value of A. Good so far?
Yes, miss.
It might take a while to process that, and that's fine. But I need you to tell me if you're following or not. Okay, well, let's practice. No, because it makes no sense wasting time. We should just do the questions. You see that same paper 2 2012? That's the one we're going to do now, right? I'm trying to enter. This might take a while to process, and that's fine. Okay, just please let me know what is confusing you right now. Even if you feel like you have to sit down by yourself and actually go through it, on your own, because some people just learn like that, right? They prefer to sit down by themselves, try to figure it out. Even if you can't do that, just please let me know if anything right now is confusing you. So this is paper 2, 2021. I mean, give me 2021. Paper 12, number 1, B, part 1. They want you to express this x cubed is equal to 10 to the power of x minus 3 in this form. I need you to notice that that form that they gave us, that's the linear form. Linear form meaning it's in the form y is equal to mx plus c. So just write down that question for me. Part 1 and 2. Write it down for me, and then I'll go through it with you. Gosh, why is that like that? Just clean up. We're doing D. Write down part 1 and 2. Let me know when you finish so I can go on the board and go through it.
Yes, miss.
Okay, what did the question ask you? And what did they give you? Well, they gave you this exponential equation, x cubed is equal to 10 to the power of x minus 3. And what did they ask you to do with this? Well, they asked you to write it in this form. Log of x to the base 10, so that's an x, right, is equal to ax plus b. And I told you that I need you to notice over time it would become easier, right? Now this right here, what they gave us, this is the linear form. And what do I mean by linear form? Well, we said that's y is equal to mx plus c. Okay? Everybody good so far?
Yes, miss.
Yes, miss.
Okay, and if I compare these two, right? The form log of x to the base 10 is equal to ax plus b. If I compare these two, right? Compare this to the linear form y is equal to mx plus c. I would be able to tell you that y, my value of y, is going to be log of x to the base 10. I can tell you that m, which is the gradient, is going to be a. So that's just me eyeballing it, right? Eyeballing the linear form and comparing it to what they gave us. So I will be able to tell you that the value of y is log of x to the base 10. M, which is my gradient, is going to be equal to a. I can tell you then x, well, x is x. And then b, or c, b is equal to c, right? That's just me looking at the both equations and comparing them. Okay, just pointing that out, right? So how do we write this into linear form? Well, I told you when we're doing that, the first thing you want to do, the first step, I'll do a PowerPoint on this, right? It's just because of today. The first thing you want to do, I said, to write log on both sides of the equation. So let me just write it up here, right? I need some space. This is what they gave us. And I told you to write it in linear form, which is in the form y is equal to mx plus c. The first thing you want to do, write log on both sides of the equation. That's the first step. However, you would notice that this is not in the form y is equal to mx plus c. We need it in that form. That form is called the linear form. So what do we do now? Well, you apply the laws that you know in order to rearrange this equation to get it into linear form. Y is equal to mx plus c. But in this case, they want the log of x to be 10 is equal. Yeah, same thing, right? Linear form. So what do? You use your laws. What law can you use here? Well, you would say log of x cubed is equal to, what can you do here? That's what you should be asking yourself, right? Let me just erase this. Start from scratch. Well, we know a law that says n log m to the base a is equal to log of m to the power of n also to the base a. So according to that rule, right, I can rewrite this equation that I have like this. X minus 3 log of 10. Right? That's just me using my rule, right? So all I did, you see this up here, Oh my gosh. The power, I brought it across and I put it here, right? So that's what the law states. We learned that law already. However, this is still not in linear form. It's not in this form, right? We need to get it in that form because that's what the question asked me. The question asked me to write it in this form. Log of x to the base 10 is equal to ax plus b. So you should ask yourself, how can I go from this to this? Well, this is like okay. So what can you say here? How am I going to rewrite it as that? Well, remember when I told you, whenever you see log by itself without a base, we assume that the base is 10. So I assume that this base is 10. I assume that this base is 10. If you look here, that's the same number, right? And we know a law that states log of a to the base a is equal to 1. Whenever these two numbers are the same, my answer is going to be 1. So what can I say then? Oh, shucks. What can I say then? Log of 10 to the base 10 is the same as saying 1. That's why I can rewrite this equation as 3 log of x to the base 10 is going to give me, remember we said log of 10 to the base 10 is 1, and anything multiplied by 1 is itself, right? So this is x minus 3. However, this is still not in this form. We need to get rid of this 3. But how? How are we going to get rid of that? Well, we just divide both sides by 3. If I divide both sides by 3, divide by 3, divide by 3, this would cancel. And what I remain with is log of x to the base 10 is equal to x minus 1. This right here, this is your answer. Log of x to the base 10 is equal to x minus 1. Everybody good with that? If you don't
Yes, miss.
think,
Excuse me, just saying that how we have about 5 minutes remaining.
okay, thank you. Anybody has any questions about this? Yes, no?
No, miss, I'm following.
Okay. I was trying to find too many things on the screen at the same time. If I do, like if it looks confusing, just let me know, right? And I'll erase something. Because I would know if you're confused with all the things on the board at the same time. Okay, the second part of that question. So now that we know this is our answer, they told us to identify the gradients. How are we going to do that? Well, you need to be able, you see the form y is equal to mx plus c? You need to be able to tell which one is y. You need to tell which is, oh gosh. You need to be able to tell what is y, what is m, what is x, and what is c, based on the equation that you have, right? So looking at this, I would say this right here, that's my y. This is m. X is, well, x is x. And then minus 1 is going to be c. What did they ask me in part 2 of that question? They asked me to identify the gradient. We know that gradient is m. And according to what we just did, m is equal to a third. And that would be your answer for that question. The gradient is a third. Everybody good with that?
Yes, miss.
That's one person.
Yes, please.
Okay, well, end the meeting. Well, I have the meeting. I would end the meeting